Look up at the night sky. For all of human history, there has only ever been one moon watching over Earth, silent, constant, familiar. It feels permanent, unchanging, as if it has always been there. But what if that isn't true? What if, long before humans existed, before dinosaurs walked the planet, before even oceans fully formed, Earth once had two moons? Not a metaphor. Not science fiction. But a possibility modern scientists are now seriously exploring. And if it's true, it completely changes how we understand the birth of our world. Because hidden in the moon's strange shape, its uneven crust, and its mysterious internal structure are clues that suggest something extraordinary happened in Earth's earliest years. Something violent. Something cosmic. Something that may have created not one, but two natural satellites orbiting our planet. Tonight, we're going to uncover the forgotten story of Earth's possible second moon, where it came from, why it vanished, and how traces of it may still exist today. And the truth is far more dramatic than you imagine. To understand how Earth could ever have two moons, we need to travel back over 4.5 billion years, to a time when the solar system was still forming, and chaos ruled the young planets. Earth wasn't the calm blue world we know today. It was a molten, volcanic hellscape constantly bombarded by massive space rocks. Planets were still colliding. Moons were still forming. Nothing was stable. This was the era of cosmic violence. And according to the most accepted theory, our moon was born from one of the most catastrophic events in Earth's history. A Mars-sized object, often called Theia, slammed into the young Earth at unimaginable speed. The impact was so powerful it didn't just leave a crater. It partially melted the planet. Chunks of Earth's crust and material from the impactor were blasted into space, forming a massive ring of glowing debris orbiting Earth like a fiery halo. Over time, gravity pulled that debris together. And from that swirling disk, our moon formed. At least, that's the simplified version. Because newer simulations reveal something far more complex. When scientists ran advanced computer models of this impact using modern physics, they noticed something unexpected. The debris didn't always form one single moon. In many scenarios, it formed two. One large moon, similar to the moon we see today, and a second, smaller companion moon forming from leftover material in a nearby orbit. This smaller moon wasn't tiny either. Some models suggest it could have been hundreds of kilometers wide, large enough to be visible in Earth's sky as a bright second lunar body. Imagine ancient Earth with two moons rising together. Two glowing spheres drifting across the night sky. Two gravitational forces shaping tides, volcanic activity, and even the planet's rotation. For millions of years, Earth may have had a celestial dance of twin moons locked in orbit. But if that happened, where did the second moon go? Why don't we see it today? That's where the mystery becomes even more fascinating. Because gravity is never peaceful. The two moons wouldn't have stayed perfectly balanced forever. The larger moon, our current moon, would slowly pull on the smaller one. Their orbits would shift. Over time, the smaller moon would spiral closer and closer. Not toward Earth. Toward the larger moon. And eventually, a collision was inevitable. But this wasn't a violent crash like the Theia impact. It would have been slow. A cosmic merger. The smaller moon gently smashing into the larger one at low speed, spreading its material across one side of the moon's surface. And according to scientists, this may explain one of the moon's greatest mysteries. Because one side of the moon is very different from the other. The near side, the one we see from Earth, is covered in dark volcanic plains. The far side is thicker, more mountainous, and has a much heavier crust. For decades, no one understood why. Until the double moon theory offered a shocking answer. What if the far side of the moon is actually the remains of Earth's lost second moon? A smaller moon that collided and fused into the moon we know today, permanently altering its structure. In other words, part of the moon may not have formed with the rest of it. Part of it may be a cosmic scar from a vanished lunar companion. And this isn't just speculation. Space missions have measured gravitational differences, crust thickness variations, and strange geological patterns that match what scientists would expect from a merged moon body. The moon isn't uniform. It's stitched together, like two worlds forced into one, which leads to an astonishing possibility. Every time you look up at the moon, you may be looking at the remains of Earth's second moon, a ghost satellite fused into lunar history. A silent reminder that our planet once had a twin companion in the sky, and lost it. But this raises even deeper questions. How long did the second moon exist? What effect did it have on Earth's tides, climate, and early life? And could similar double moon systems exist around other planets right now? Because if it happened here, it may be happening across the universe. And what we're only beginning to understand is that Earth's early history was far more chaotic, violent, and mysterious than textbooks ever suggested. In the next part, we'll explore the physical evidence hidden inside the moon itself, the strange measurements, anomalies, and space mission data that push scientists to take the two-moon theory seriously. And the discoveries are mind-blowing. If the idea of a vanished second moon sounds like cosmic fantasy, the surface of the moon itself tells a very different story, one written in stone, gravity, and ancient scars frozen in time. For centuries, humans only saw one face of the moon. Tidal locking ensured the same side always stared back at Earth, calm and familiar. It wasn't until space exploration that we finally witnessed the far side, and when we did, scientists were stunned. It looked like another world. The near side was smooth, dark, and shaped by ancient lava flows. Vast plains known as Maria stretched across its surface, evidence of molten rock once flooding massive impact basins. But the far side? It was rough, heavily cratered, towering with thick, mountainous crust. Almost no volcanic plains. Almost no smoothing. Just raw, ancient terrain. At first, researchers assumed random chance had created the difference. But the more they studied it, the stranger it became. The moon wasn't simply uneven. It was structurally asymmetric. Measurements from orbiting spacecraft revealed that the crust on the far side is significantly thicker, in some places nearly twice as thick as the near side. That shouldn't happen naturally in a body that formed from one spinning disk of debris. Gravity should have spread material evenly. Heat should have balanced the interior. Yet it didn't. Something had added mass to one side of the moon. Something enormous. Something external. And that's where the missing moon theory suddenly became incredibly powerful. If a smaller moon slowly spiraled inward and merged with the larger one, it wouldn't blend perfectly like melting metal. Instead, it would splatter its material across one hemisphere, thickening the crust, altering geology, and reshaping gravity. Exactly what scientists observe today. It would be like sticking a second planet-sized layer onto half of the moon. And the evidence lines up almost too well. Gravity mapping missions revealed hidden mass concentrations beneath the lunar surface. Some areas pulled spacecraft slightly off course, invisible structures buried deep within the moon. These anomalies matched what you'd expect from massive chunks of foreign material embedded inside a planetary body. Not volcanic. Not impact-related. But structural additions. Almost like the moon had been patched together. Even more fascinating, the chemical composition of some lunar rocks from the far side differs subtly from the near side. Not dramatically, but enough to suggest they didn't all originate from the exact same molten source. Two moons. Two formation histories. One merged world. And the timing makes sense too. Computer simulations show the smaller moon would likely have existed for tens of millions of years before merging, long enough to influence Earth's tides and rotation, but short enough to vanish before life ever began recording the skies. During that era, Earth's oceans were forming. Volcanoes were shaping continents. The atmosphere was evolving. The gravitational pull from two moons would have created extreme tidal forces, far stronger than what we experience today. Massive tides could have surged hundreds of meters high, crashing across young coastlines, mixing chemicals in shallow waters, and possibly accelerating the conditions needed for life to emerge. Some scientists even speculate that life's earliest building blocks may have benefited from these violent tidal cycles. In a strange way, Earth's second moon may have helped life begin, and then disappeared, absorbed into the moon we see today. A celestial sacrifice that shaped both our planet and our satellite. But the story doesn't end with geology, because the dynamics of a two-moon system would have dramatically affected Earth's rotation. Early Earth likely spun much faster than today. Days could have been only 5 or 6 hours long. The gravitational braking caused by two moons would have slowed the planet more efficiently, stretching days longer and stabilizing Earth's tilt. That stability is one of the key reasons Earth developed a relatively calm climate compared to chaotic planets like Mars. So in a way, Earth's lost moon may have helped create the stable environment that allowed complex life to eventually flourish. Without it, our planet may have remained wildly unstable, extreme seasons, violent climate swings, and possibly no advanced life at all. Which leads to a haunting realization. You might not exist without a moon that no longer exists. Every human story, every civilization, every moment of history may trace back to a vanished celestial companion. But there's something even more mysterious. Because if two moon systems naturally form after massive planetary impacts, then Earth may not be unique. Young planets across the galaxy could be forming multiple moons right now, some destined to merge, others to be ejected into space as rogue moons drifting endlessly through the cosmos. Entire invisible populations of orphan moons may wander between stars. And some planets may still host twin moons in slow-motion death spirals, millions of years away from collision. Which means what happened to Earth may be a common cosmic process. Not a rare miracle, but a fundamental step in planetary evolution. In the next part, we'll dive into how scientists recreated these ancient events using powerful simulations, and how modern space technology allowed us to virtually rewind the birth of the moon itself. What they discovered looks like something straight out of science fiction, except it's backed by physics. And it gets even more dramatic. For most of human history, the moon's origin lived in the realm of myth. Ancient cultures imagined gods shaping it, spirits carrying it across the sky, or celestial fires forging it into existence. But in the modern age, science found something even more astonishing, a story written not in legend, but in gravity and motion. And to uncover it, scientists did something remarkable. They rewound time. Not with a machine, but with mathematics powerful enough to recreate the birth of worlds. Using supercomputers capable of processing billions of calculations per second, researchers built digital versions of the early solar system. They recreated molten Earth, the incoming planetary body, and the vast clouds of debris thrown into orbit after the catastrophic impact. Every fragment of rock, every gravitational tug, every collision, all simulated in slow motion. What they expected was simple. One moon forming. What they actually saw was far stranger. Again and again, the models produced two major clumps of material. Two growing moons. One larger. One smaller. Orbiting Earth together like cosmic siblings. In some simulations, the second moon formed closer to Earth. In others, slightly farther away. But in many cases, it survived for millions of years before its orbit destabilized. Gravity always won. The larger moon slowly stole orbital energy from the smaller one. Their paths drifted closer. Their gravitational fields tangled. And eventually, the smaller moon spiraled inward. What happened next wasn't a violent explosion. It was a slow collision, more like a planetary embrace. At speeds low enough that the bodies didn't shatter, but high enough to deform each other dramatically. The smaller moon flattened and smeared across one side of the larger moon, its crust spreading like molten clay. And when the simulation settled, the result looked eerily familiar. A moon with one thick, mountainous hemisphere, and one smoother volcanic side. Exactly what we observe today. Scientists weren't just surprised. They were shaken. Because the models hadn't been designed to create that structure. It emerged naturally from the physics. No tweaking. No forced assumptions. Just gravity doing what gravity does. And the end result matched the real moon almost perfectly. The far side became thicker. the near side thinner. The merged region became geologically complex. The internal density shifted asymmetrically. All features measured by modern space probes. It was one of those rare moments in science when a theory doesn't just fit the data, it predicts it. Even more fascinating, the simulations showed something else. The merging process would have released enormous heat inside the moon, enough to remelt parts of its crust. That heat would rise toward the side facing Earth, thinning the crust there and triggering widespread volcanic flooding. Which explains why the near side is dominated by dark basalt plains. The collision not only built the moon, it reshaped its face. In a sense, the moon we see is a scarred survivor of an ancient cosmic fusion. Half original, half absorbed. A world born from violence and unity. And the timing lines up beautifully. These events would have occurred within the first 100 million years of Earth's existence, a blink of an eye in cosmic history. By the time Earth cooled enough for oceans to stabilize, the second moon was already gone, leaving only its fused remains behind. Which explains why no ancient records, myths, or fossils ever mention two moons. Humanity arrived long after the sky had settled. But the universe left its fingerprints. Written in lunar rock. Written in gravity. Written in the shape of the moon itself. But this raises a haunting thought. If the moon absorbed its sibling, could Earth have once captured even more moons? Short-lived satellites pulled in by gravity, orbiting briefly before crashing or being flung into space. Some astronomers believe early Earth may have temporarily hosted several mini-moons over millions of years, cosmic visitors that didn't last long enough to become permanent. Even today, Earth occasionally captures small asteroids for short periods, creating temporary natural satellites that orbit for months or years before escaping. The planet is still doing what it did billions of years ago. Catching companions. Losing them. The difference is scale. Back then, the companions were worlds. And this chaotic phase may not be unique to Earth. Mars shows evidence of past moon disruptions. Some gas giants host systems where moons constantly shift and collide. Planetary evolution appears to be violent everywhere. Worlds are built not gently, but through destruction. Through mergers. Through cosmic accidents. Which makes Earth's calm present feel almost miraculous. But behind that calm lies a brutal past where moons were born, destroyed, and absorbed. And we are living on the stabilized aftermath of that chaos. In the next part, we'll explore what this lost moon may have done to Earth itself, shaping oceans, climate, tectonics, and possibly the origin of life. Because its influence may be far greater than simply becoming part of the moon. It may have helped make Earth habitable. And without it, our planet might look more like a dead rock than a living world. When we imagine Earth's distant past, we often picture a violent planet of fire and storms, but rarely do we consider how profoundly the sky itself may have shaped the surface below. If Earth once had two moons, the consequences would have been enormous. Not just visually breathtaking, but physically transformative. Because moons do more than light the night. They pull. They stretch. They reshape worlds through gravity. Even our single moon today is responsible for ocean tides rising and falling every day across the planet. Now imagine doubling that force. Two moons orbiting Earth would have created tidal surges far stronger than anything we experience now. Entire coastlines would have flooded and retreated constantly. Shallow seas would repeatedly dry and refill. Water would surge across continents in rhythmic cycles driven by lunar gravity. These weren't gentle waves. They were colossal movements of the planet's oceans. And those movements may have played a critical role in one of the greatest mysteries of all time, the origin of life. In early Earth's shallow waters, simple molecules floated freely. But for life to emerge, those molecules needed concentration, separation, heating, cooling, and repetition. The violent tidal cycles created exactly that. Pools of water would flood with nutrients, then evaporate under intense sunlight, concentrating chemicals. When tides returned, fresh material mixed in. Over and over, millions of times. This natural laboratory may have allowed complex organic compounds to form, the building blocks of living cells. Some scientists believe without strong tides, life might never have advanced beyond simple chemistry. And with two moons, those tides would have been dramatically more powerful. In a strange way, Earth's lost moon may have helped awaken life itself. But the influence didn't stop at biology. The gravitational forces from two moons would also have affected Earth's internal structure. Tidal pulling doesn't just move oceans, it slightly flexes the planet's crust and mantle. This flexing generates heat inside Earth, known as tidal heating. We see it today on Jupiter's moon Io, where intense gravitational stretching creates massive volcanic eruptions. Early Earth, under the influence of two moons, may have experienced far stronger internal heating than today. This extra heat could have fueled increased volcanic activity, accelerating the release of gases that formed Earth's atmosphere. Water vapor, carbon dioxide, nitrogen, the essential ingredients for a breathable world. Volcanoes may have erupted more frequently, reshaping continents, forming new land, and recycling minerals necessary for early ecosystems. The lost moon wasn't just orbiting Earth. It was actively shaping it. Even Earth's rotation was likely transformed. Today, a day lasts 24 hours. But billions of years ago, Earth spun much faster. One day may have lasted only 5 or 6 hours. The gravitational drag from moons acts like a brake, slowing a planet's rotation over time. With two moons applying that drag, Earth's spin would have slowed more rapidly, stabilizing the planet's tilt. This stability is crucial. A wildly tilting planet experiences extreme climate swings, scorching heat one era, frozen darkness the next. Mars likely lost much of its climate stability after losing most of its moons and magnetic field. Earth, protected by its lunar system, remained balanced. Seasons became predictable. Oceans remained liquid. Climate remained relatively steady for billions of years. Perfect conditions for complex life to evolve. So when the smaller moon merged with the larger one and vanished, its job may already have been done. It helped slow Earth. It helped heat Earth. It helped mix Earth's oceans. It helped prepare the planet for life. Then it disappeared into the moon itself, leaving behind a stable world ready to grow forests, animals, and eventually humans. Which turns the lost moon into something almost poetic. A cosmic caretaker that existed just long enough to shape Earth, and then sacrificed itself to the heavens. But here's where the story grows even more mysterious. If moons can shape habitability so profoundly, then planets across the galaxy with multiple moons may be far more likely to host life. Astronomers now consider moon systems as a major factor when searching for habitable exoplanets. A planet without moons may be unstable. A planet with one moon may be stable. A planet with several moons could be even more dynamic, perhaps ideal for early life. Which means Earth's early double moon phase might not be rare. It could be a common step in turning dead worlds into living ones. And somewhere in the universe right now, twin moons may be shaping alien oceans under distant stars. Life elsewhere may owe its existence to vanished moons just like ours. In the final part, we'll step back and look at the bigger cosmic picture. What Earth's lost moon teaches us about planetary evolution. How violent chaos creates habitable worlds. And why the universe may be filled with planets that once had more moons than they do today. The story doesn't just change how we see the moon. It changes how we understand life in the universe. When we piece together everything science now suggests, the violent birth of the moon, the strange asymmetry of its surface, the simulations of twin lunar formation, and the profound effects of extreme tides, a powerful realization emerges. Earth's history was never calm. It was forged in chaos. Worlds collided. Moons were born. Moons were destroyed. And from that destruction, stability emerged. The idea that Earth once had two moons is not just a fascinating curiosity. It may represent a universal process of planetary evolution. Across the cosmos, young planets form inside swirling disks of gas and debris. Massive collisions are common. Satellites are created in clusters. Gravitational interactions reshape systems constantly. Some moons survive. Some collide. Some are ejected into deep space. What remains is often a simplified, stable system, the quiet aftermath of ancient violence. Our moon may be the final survivor of a once crowded sky, a winner of a cosmic survival contest, a fused relic carrying the remains of a lost companion within its crust. And Earth may be the beneficiary of that violent pruning. Without those early chaotic interactions, our planet might never have achieved the balance necessary for life. This changes how we interpret the universe. For decades, scientists searched for calm solar systems like ours, assuming stability was required for life. Now the thinking is shifting. Violence may be the creator of stability. Massive impacts may be the architects of habitable worlds. Lost moons may be essential steps in shaping climates, oceans, and planetary rotation. In other words, destruction may be a necessary ingredient for creation. And once you see it that way, Earth's past becomes part of a much larger cosmic story. Not an exception, but a pattern. Astronomers studying distant star systems now observe planets with thick debris disks, signs of recent collisions. Some exoplanets show unusual orbital wobbles that hint at missing moons or past mergers. Others may currently host multiple large moons slowly spiraling toward one another, locked in gravitational dances that will eventually end in fusion. Somewhere in the universe right now, a moon may be dying, drifting toward its larger sibling, destined to merge and reshape a planetary system forever. Somewhere else, a young planet may be experiencing massive tides under the pull of twin moons, unknowingly preparing the chemical stage for life. And someday, intelligent beings on that world may look up at a single moon in their sky, unaware that their planet once had two. Just like us. The moon above Earth seems timeless. But it is a survivor. A monument to ancient chaos. A stitched world formed from catastrophe. Every crater tells a story. Every uneven layer holds secrets. And hidden inside its structure may lie the remains of a vanished celestial companion that helped make our world livable. Which gives the moon an entirely new meaning. It's not just Earth's satellite. It's Earth's history. A fossil of planetary violence. A reminder that even the calmest skies were once battlefields. So the next time you see the moon rising, glowing pale above the horizon, imagine what the sky once looked like billions of years ago. Two moons drifting together. Casting twin shadows across alien oceans. Pulling tides across newborn continents. Shaping the future of life long before life existed. One moon destined to disappear. One moon destined to remain. And a planet forever changed by both. Because Earth didn't simply inherit its moon. It survived a cosmic storm to keep it. And in that storm, it may have briefly held two.